Hi friends, welcome to my YouTube channel. Today in this video we will learn in details about Uplinkfast, Backbonefast, Portfast and RSTP. I have taken three switches here and one of the switch here is going to be a root bridge. The one which has got the lowest priority will always be the root bridge. So let's assume that this switch over here is having a lowest priority. This is our switch A. Okay, my switch A. All right, and this is my switch B, and this is my switch C. So whenever there is, suppose if there is a tie in the priority between these three switches, then the tiebreaker will always be the lowest MAC address. So let's assume that this switch A here has got the lowest MAC address or the lowest priority, and hence this is our root bridge. So you already know that for a root bridge, the ports connected on that particular root bridge will always be a designated port. So it will never have a blocking port and it will never have a root port. Okay, so let's just mark that details here. So this port is going to be a designated port. So DP, designated port. Okay, and the the opposite port here, let's assume that this is our root port. Okay, and for this switch we have this port is our root port. Okay, now we got our root port. Let's identify which is our blocking port. Blocking port is also called as a alternative port. So I will assume that this port here, this is going to be a designated port, and this port here that you will see, I'm going to mark that in this color, a different color. This is my blocking port or alternate port. Okay. Oh, all right. So excuse me for my font because I'm using a I'm not using a digital pen. So um, now we need to understand before we move to Uplinkfast or the Backbonefast or the Portfast, we need to understand what is direct link and indirect link. So direct link is the link which is directly connected on the switch that has alternate port. So this is going to be your main switch that we are going to concentrate, and the link which is connected to this switch in which we can see there is an alternate or a blocking port. This link is called as a direct link. I will just mention it in short form. It's direct link. And what is indirect link? The link which is opposite to the switch, okay, which has the alternate or a blocking port. So which is that? This is our link which is opposite to this. So make sure that your indirect link is the link which is not connected to the switch which has alternate or a blocking port. Okay, so this is my indirect link. Okay, so let's understand our classic spanning tree. Uh, when you are observing one of our link is down, right? You will see that the convergence time is the time in which the port will try to listen and then learn the changes in the topology. Okay, so what is the necessity to have a uplink fast? Okay, so uplink fast transitions port in blocking from the blocking or alternate state to forwarding state immediately. Okay, so that's the only reason that you will have a uplink fast. So suppose this link goes down. Okay, if you see that your direct link goes down, and assume that you have a uplink fast applied on this particular switch. See, you have configured this. So what happens is it usually takes 15 seconds to listen and 15 seconds to learn before the blocking port turns to forwarding state. So altogether, a 30 seconds of convergence time is required for a classical spanning tree. But if you have an uplink fast, then this 30 seconds of time can be saved. Okay, so immediately your alternate or a blocking port will transition from the blocking state to a forwarding state without waiting for 30 seconds. Okay, so let's just understand in detail. So typical spanning tree protocol, which is our classical or a normal spanning tree protocol convergence time, you know that it takes 15 seconds to learn. So this block has to understand, okay, this link is down now, okay, and it will take time here because this root bridge will no more have a root port connected, but still this switch will need some time. Okay, so 15 seconds for what? Listening, and 15 seconds for learning. Okay, I'll put just this learning stage. All right, so that's going to be 30 seconds. But if you have a uplink fast, okay, in uplink fast, if you have, you will be able to save this 30 seconds of convergence time, and you can see your alternate port will immediately transition from the blocking port to a forwarding state. Okay, so that's the difference between your uplink fast configuration. So now let's understand what is the backbone fast. So backbone fast, let's take an example here that you no more have any link down here. So I'm just going to delete this. So you can assume that this link is up. Okay, so this link is up and running. This is fine. Your link is up. Okay, but this link over here, indirect link, okay, that is indirect link connected from this switch A to switch B, if this goes down, then what happens? There is a 20 seconds wait time. So this alternate the alternate port here, it will wait for the BPDUs to be passed from root bridge for 20 seconds. Then it realizes that there is no information coming from this root bridge. I'll just mark it as um, your wait time. Okay, there is no BPDUs. So what happens? Your alternate port will go to listening state for 15 seconds. Okay, I'll just mark it as LSN. And then goes to learning state for another 15 seconds. Okay, so all together, so 20 plus 30, 20 plus 30, you got 50 seconds of convergence time when you are taking an example for a indirect link being down. Okay, so this is for your Backbonefast. So if I configure Backbonefast on the switch, then you can save this 20 seconds, and within 30 seconds of convergence time, your alternate or a blocking port will become a forwarding state. Okay, it will change its state from blocking to forwarding state within 30 seconds. So that's the difference between the uplink fast and the backbone fast. Now we have one more information here, which is called as a port fast. But make sure that you do not configure port fast on any of the switches. I mean, not between the trunk links, not between the switch and switch, but because always you will connect a switch and the end use device. So it can be your servers, your PCs, or printers. Okay, so you will have this port fast configured only between the switch and the end user devices. All right, so in port fast, so what happens in port fast, here also you can see that your convergence time will be within just 1 second. Okay, within 1 second, the alternate or a blocking port will change to forwarding state. Okay, so Cisco has come up with a new and advanced technology called as RSTP. Here all it requires is just 1 second, and it has inbuilt features which has uplink fast included, backbone fast included, and yes, your port fast is also inbuilt within the RSTP. So no more 30 seconds of convergence in RSTP. So it is a combination. Okay, it's a combination of all these three features: the port fast feature, the backbone fast, and your uplink fast. However, the path calculations will remain the same as a STP. Okay, so let's understand in more details in our lab. Okay, so we have three switches connected here, and I have not done any configuration, but all I have just found the details using show spanning tree in my global configuration mode for all these three switches, and I found that this switch over here is the root bridge. Okay, the reason is because this switch has got the lowest MAC address. So this switch is my root bridge, and I have my designated port here, which is in forwarding state. Okay, then the opposite uh, port here that you're seeing is my root port, which is connected towards my root bridge. And here is another root port, which is connected to my root bridge. Okay, and the other port here is my designated port, and you can see here kind of an orange color symbol here, which is indicating my blocking port, and I also call it as alternate port. Okay. So now let's assume which is my direct link. So as I already said that direct link is the link which is connected to the switch which has blocking port. So this is my direct link, okay? And the opposite link which is not in any connection to my upstream switch where you can see the blocking port, and hence this link here which is opposite, this is my indirect link. So usually when since this is a packet tracer, I will not be able to configure this modes over here because I don't think that you have that option even if you configure, and I tried that, so I could not find the option here to configure uplink fast or Backbonefast. So just let's understand this for let's understand that if this link goes down, okay, this link goes down, let's just assume, okay, so let's see what happens. Okay, we will see but before we go to our configuration and find out what happens, let's imagine if there is a uplink configuration done here, okay, you will not be seeing that 15 seconds of listening and 15 seconds of learning, and this port could have easily converged from blocking port to a forwarding port immediately within 1 second. But since I don't have that feature in packet tracer, so let's see what happens now. I'm going to shut down this port here. Okay, let's shut down this fast Ethernet 0/2 in order to make this direct link down. So I'll go to my command prompt here and go to enable mode, configuration, interface fast Ethernet 0/2. That is the link I will need to shut down. And yes, so yeah, you can see that the link is turning from green to red. So let's just run this command and see show spanning tree, and you will see that it's gone to forwarding state because of RSTP, which is already configured on all these switches. So I have my RSTP configured here to show spanning tree. Show spanning tree protocol here, which is running, is RSTP. So you are not saying that listening and learning because it's already configured to RSTP. Let me go ahead and remove this RSTP configuration and see what happens. So I have removed the rapid spanning tree protocol. Let's see that 15 seconds of time that you can observe for the blocking port to go to forwarding stage. So I go to switch 0 and I have removed the RSTP now. So let's see here, show spanning tree. I need to shut down this port here. So I'm going to get this link up now. Okay, so fast Ethernet. So go to interface, fast Ethernet 0/2, give no shut command. Okay, so the link is up. Let's just wait until this link turns green. So if you want to verify which is your root bridge, in the meanwhile it's going to green. Let's just find out how do you find the root bridge. Just give show spanning tree, and you can see that this is the root bridge. It says this bridge is the root. Okay, so yes, so this is my blocking port here. So let's just try now. I have removed RSTP because we want to understand the delay in convergence if you don't have RSTP. Because when the RSTP was there, you saw that the blocking port immediately changed to forwarding port. Okay, just within 1 second. So let's see that difference now when RSTP is removed on the switches. Okay, so I go to global configuration mode and interfaced fast Ethernet 0/2. I'm going to shut down this direct link now, and I say shut down and go to the same switch, and let's see the changes of listening and learning. You see that the change in status from listening and shows spanning, you will see learning, yeah, and it's taking another uh, some time here to show spanning tree and still learning. Show spanning tree. Yes, finally it's the alternate or the blocking port has changed itself to a root port, and finally it's in forwarding state. So this has happened because you've removed the RSTP. So the best um, feature to have this convergence time saved is to use RSTP. Okay, so similarly, let's also see this is our backbone. If you have a Backbonefast configured on the switch, okay, you will see that 50 seconds of time delay. But let's see that because by the time let me just get this link up and running now, and then we'll shut down this and another link which is there in the Backbonefast, I mean in the indirect link. So I go back to global configuration, interface, fast Ethernet 0/2. I want to get this up and running, so I go no chat, sorry. Okay, no chat, okay, and it's back up. Okay, so now if you are going to shut down this port here, okay, my indirect link, so the blocking port is going to wait for 20 seconds here, assuming that it's going to receive some BPDUs from the root bridge, okay, but it then realizes that this link is a shutdown link, and it will listen to the 19 seconds delay that it starts listening, and then sorry, Yeah, the 15 seconds of delay for listening, and then it learns that, okay, there is no BPDU coming from the root bridge. So it then goes to forwarding state. So your blocking port will take 50 seconds for convergence to change its state from blocking port, from the blocking state to a forwarding state. Okay, but if you have the Backbonefast configured, then you don't need to worry about this 20 seconds because it just takes 30 seconds for the convergence. But yes, so as we already learned that if you have RSTPs on all the switches, then you can avoid all these delays. So right now I have not added any RSTPs on the switch. So let's just see the delays in time convergence. Let's just shut down this link and see what happens. So here I will just shut down this link. Yeah, this link, fast Ethernet 0/2, and see what happens. Okay, configure mode, interface, fast Ethernet 0/2. I want to shut down this port. Okay, let's go back to our upstream switch. You will see it's going to take 50 seconds compared to your direct link, which was down earlier. So show spanning tree. It's still taking that 20 seconds to wait the BPDU packets from the root bridge. It started to learn. Show spanning tree. It's learning. Show spanning tree. Still learning. Finally, it's going to forwarding state. Okay, so your alternate port here, that's fast Ethernet 0/1, has changed from blocking to forwarding. Okay, so that's all about your convergence time differences for your direct link and indirect link. But if you have RSTP on all these switches, and let's just go ahead and configure RSTP and turn off these links, and you will see there is no delay. So I'll just go to my switch here on all the switches, configure RSTP, spanning tree mode, RSTP, okay, just exit out. I'll go to another switch, spanning tree, mode. Yeah, so it's configured. Last switch left here. So let me also get this link. Okay, let it be in shutdown state because I want to make sure that there is no delay. So spanning tree mode. Okay, yes. So you still have this link down. My indirect link is still shut down, and initially you have seen that it took 50 seconds for convergence, with 20 seconds for the wait time for BPDU packets from root bridge and 30 seconds of listening and learning. So, but now, since you have configured the RSTP, you can see it hardly takes just 1 second for the alternate port to switch to forwarding state. Okay. Yeah, so your fast Ethernet 0/1, which is your alternate port, has successfully changed to forwarding state within just 1 second. Now, let me get this link back up, okay, and configure interface fast Ethernet 0/2, no shut. All right. Okay, so now you can see that now since you have the RSTP configured, even if you will shut down this port here, one of my direct link, I'm going to shut down this fast Ethernet 0/2, configure interface fast Ethernet 0/2, and I'm going to shut down. And here within 1 second, you can see that this blocking port will change to forwarding. Let's see that. Show spanning tree. Yes. So you will not see any listening and learning anymore. It immediately has changed the status from um, directly from the blocking port to a forwarding port immediately within just 1 second. Okay, so that's all about the RSTP. I hope this video has been helpful to you all. See you in the next video, but please do not forget to hit the like button and subscribe to my channel for my new videos coming up.